Welcome to this lecture on trigonometric equations involving multiple angles. There are no new concepts here. We'll just apply what we have learned before, and then what they put on top of that here is that we have, for example, have 3x or 3 theta or 4 theta, something like that. Just going to do a couple of examples for this lecture. So this one here obviously is going to come out to 3x equals inverse tangent of 1, and solutions that we're going to come up with will be 3x equals, I already put this, let's see, 3x equals, and of course the inverse tangent of 1 is going to be 45 degrees. We have a second solution at 225 degrees in the third quadrant. However, the problem description says that we should look at all the solutions over all x values. So we would have to add 180 degrees to each of them. That's because the tangent is periodic every 180 degrees. Well, by adding k times 180 degrees, we automatically get to 225 degrees, so we don't need to list that one. So we would have 45 and 225 and 405 and 585 and so on. And of course, we need to divide by 3. So I do that right here. And then it actually says to determine them in radians. So we're going to come up here with pi over 4. Let's see. There are pi plus k times pi, and that divided by 3. And you can easily check this here. If you plug in the pi over 4 divide by 3 in right here for the x, the 3's of course cancel. You have pi over 4, tangent of pi over 4 comes out to 1. And then you do the same thing by putting another pi on top of that. 5 quarters pi divide by 3. The 3 cancels with this one here. 5 quarters pi, take the tangent of that, you come up with 1, and so on. Okay, one more example. As I said, relatively quick. Solve for theta. Here we have sine 3 theta. We didn't encounter an identity for it. However, we have sine theta 3 theta here, and then we have sine square 3 theta there. So we just substitute a u for it. For example, u equals sine theta, and we come up with a quadratic equation that says 2u squared minus u minus 1 equals 0, and it would be nice if I can factor that. So let's see, 2u, and then here's a u, and then 1. Somewhere we're going to have a plus 1 and somewhere in minus 1. I'm pretty sure that we have a minus 1 right here and a plus 1 right there. And if I check that farther than my head, that is indeed correct. So we're going to resubstitute the sine theta into this one. Oops, didn't I make a mistake earlier? But it's of no consequence really. Of course, I substituted u equals sine 3 theta, but notice it's very easily correctable, so I don't have to really repeat myself here. Okay, so what I'm going to come up with, theta equals somewhere, let's see. So theta equals, on the first one, we're going to have sine 3 theta equals negative 1/2. So at negative 1/2, of course, the reference angle will be 30 degrees. We're going to be in the third and fourth quadrant. So we're going to have 210 and 330 degrees as a solution. And then we're actually supposed to add the periodicity here of 360 to it, so plus k 360. And then because we're actually solving sine 3 theta, we have to divide by 3, so we come up with 70 degrees plus k 120, and here of course 110 plus k 120 degrees. And then I add this degree sign in here, make it look a little nicer. Oops, I got a 1 here, 110. That is the solution for the parentheses on the left-hand side. And again, you can check that on your calculator. For the one on the right-hand side, we come up with sine 3 theta equals plus 1. Of course, that only works for 90 degrees. And again, we would have to add 360. But then we have, of course, 3 theta, so we divide by 3, and we come up with 30 plus k 120 degrees. And of course, this time around, because sine 3 theta equals plus 1, we come up only with one solution here. And with that, that really was it for the lecture on trigonometric equations involving multiple angles.